Good evening, everyone. So this is welcome to my channel Mathematics Road. This is Mathematics Road. In the previous video, which I have made, which is not published right now, it is just going to be published. So here, in the previous video, we have discussed about the quadratic equation related to the complex number. Now we are doing the example of miscellaneous exercise, and now after completing, this is the example, last example of NCERT complex number. After this we will start the miscellaneous exercise. So after this we will start the miscellaneous exercise. So here the question says that convert the question example says that they convert the complex number in the polar form, where z is equal to I minus 1 divided by upon cos pi by 3 plus I sin pi by 3. So first of all we will make it in standard form. This is not written in standard form, so we will write it in standard form because we have to find in polar form. So first of all we will find in standard form a plus ib, or you can take x plus iy as it depends upon you. So now solution. Z is equal to I minus cos, it is cos pi by 3 means cos 60 degree means 1 by 2, and then sin pi by 3, this is root 3 by 2. Sin 60 degrees root 3 by 2. You know it from the trigonometry class 10th. Now this is 1 by 2. In place of cos pi by 3 we have written 1 by 2, and then I into root 3 by 2. Now we will take LCM in the denominator. So I plus 1 plus root 3i divided by 2, and this 2 will come in the numerator. So 2i minus 2, I'm just multiplying the each term of the numerator, and 1 plus root 3i. Now we have to convert it as standard form, so therefore we have to multiply by its conjugate. So 1 minus root 3i, conjugate of the denominator. So multiply by conjugate of denominator, which is 1 plus root 3i, that is 1 minus root 3i. So I have multiplied numerator and denominator by 1 minus 3i. So hope up to this you are understanding. So 2i into I, so 2i, now 2i into root 3i minus root 3i, so 2 root 3i square minus 2 into 1 minus 2 into plus root 3i, so it is plus 2 root 3i, and in the denominator a plus b, this is a plus b and this is a minus b, so it is a square minus b square, so it is 1 square minus root 3i whole square. Now 2i minus 2 root 3 iota square is equal to minus 1 minus 2 plus 2 root 3 iota divided by 1 minus 3. See, 1 minus 3 root 3 will square, so it becomes 3i square. So now here it is 2i plus 2 root 3 minus 2 plus 2 root 3i, and now put the value of I minus 1, I square is equal to minus 1, so I am putting over here. So now I am writing real part in first 2 root 3 minus 2 and then 2i plus 2 root 3i imaginary part. So here it is my minus plus, so 3 plus 1, so it is 4. So see, in the numerator 2 is common, we can take. So 2 is common. If I will take, then root 3 minus 1, then iota plus root 3i divided by 4. So 2 and 4 will cancel, so 2. So this can be written as root 3i, root 3 minus 1 upon 2, and then take I common here. So it is 1 plus root 3 iota divided by 2. So it is in the form of x plus iy. So it is in standard form. So now we will have to find out the polar form of this complex number. So if we will equate the real and imaginary part, we see that x is equal to root 3 minus 1 by 2 and y is equal to 1 plus root 3 by 2. So r is equal to root under x square plus y square. R is the modulus of the complex number. It is the distance of the complex number which is represented in argand plane as a point from the origin, and where theta is the argument which makes the positive angle, positive direction of x-axis. So here just a minute. Now here we have root 3 minus 1 by 2 whole square, and this is root 3 plus 1 by 2. We can write so root 3 plus 1 by 2 whole square. So this becomes here root 3 minus 1 whole square, and then plus root 3 plus 1 whole square, and LCM will be 4. As you know that a plus b whole square plus a minus b whole square is equal to twice a square b square. So here we can write twice root 3 square and then 1 square. Otherwise we have to simplify both divided by 4. So now so this square root of 2, and this is square root of root 3 square, so it is 3 plus 1 and divided by 4. So you know it is 2 into 4 divided by 4, so root 2. So r is equal to root 2. We have got r is equal to root 2, and which also gives the modulus of the complex number. Now we have to find argument of z, as z is equal to, I am again writing the form root 3 minus 1 divided by 2 plus 1 plus root 3 by 2i. This is the standard form of the given complex number. So here x plus I by, if we are comparing x and y, I have already written, and here you see x is equal to this and y is equal to this. So therefore tan theta is equal to, you have to take modulus of y by x. So y is equal to 1 plus root 3 divided by 2, and this is root 3 minus 1 whole divided by 2, and then denominator will cancel out. So now it is equal to root 3 plus 1 and then root 3 minus 1, as we will find out tan 75 degree. As you know that tan 75 degree can be written as tan 45 degree plus 30 degree, you know. So from trigonometry, tan A plus, see whether it is coming or not, tan A plus B, we will use the formula tan A plus tan B. Why I have used this? Because here is minus. So 1 minus tan A into tan B. In place of A, tan 45 you have to write, and C, tan 30 degree you will write over here. 1 minus tan 45 and then tan 30 degree. So tan 45 1, tan 30 degree 1 by root 3, and here 1 minus 1 into 1 by root 3. You have to learn Magapit, and no need to find out in this way like me. Root 3, so root 3 will cancel. So we are getting root 3 plus 1 by root 3 minus 1. So it means that tan 75 degree is equal to this. So we can write over here modulus of this. So this is greater than 1, and this is obviously positive, and so it is also positive. This modulus will be root 3 plus 1 divided by root 3 minus 1. This can be written as tan 75 degree. So tan 75 degree means theta is what? Acute angle. Acute angle lies and we see that the complex number here, x is also positive. See, x is positive and y is also positive. Why x is positive? Because the approximate value of root 3 is 1.732. So 1.732 minus 1, so it is 0.732, and here it is, and whole divided by, this is whole divided by 2, so obviously it is greater than 0, and this value is 2.732 by 2 is obviously greater than 0. So if x and y both are greater than 0, it means that the complex number z lies in which quadrant? In first quadrant. Okay, in first quadrant. So in first quadrant, argument is always acute angle or right angle. It will right angle also. So argument of z is theta, and theta is 75 degree. Now we will write in radian. 75 into pi by 180. It is 15 when you 15 2 jo 15 5 jo 75. So 5 pi by 12. So now argument is equal to this. We have calculated over here. Now we will write the polar form. So polar form of the complex number, we know it. I'm just writing with the other pen. So polar form of Z, complex number Z, R cos theta plus I sin theta. You can also write R cos A, argument of complex number Z, plus I sin A, argument of complex number Z. In this way you can also write. So R is root 2. We have already calculated earlier. R is equal to, I think, just root 2 I have calculated over here. R is equal to root 2. Here is R is equal to root 2. And now C, and argument is 5 pi by 12. So cos 5 pi by 12 plus I sin 5 pi by 12. So this is the polar form of the complex number. So little bit of problem in the throat. So for that I am extremely sorry. So this is the answer. Hope you will understand it. Now we are coming to the next question, which is from the question number 1 of miscellaneous exercise. So now this is the question. Miscellaneous exercise on chapter 5 means complex number. First question is, here evaluate the value. We have to find out the value of this. So as you know that the solution, I to the power 18 plus 1 by I to the power 25 whole to the power 3 is given. So 18 you will divide by 4. 4 4 just 16. 16 means here we are getting 2, and here 25 you have to divide by 4. 4 6 24, we are getting 1. So it means that I to the power 18 can be written as I to the power 2, because the remainder is 2. Since I to the power 4 is equal to 1, this you know, and I square is equal to minus 1. Now I to the power 25, you can write I to the power 1, because here is remainder is 1. So whatever the remainder will be, you will have to put the remainder, because I to the power 4 is equal to 1. So this is I. So now we can write this whole thing. This is minus 1 plus 1 by I to the power 25 whole to the power 3. So then this can be written as minus 1 plus 1 by I. And as you know that if you will rationalize it, I. So here is power is 3. So it is minus 1 plus I divided by I square. You have to rationalize I, so you will multiply by I, and I square is equal to minus 1. Therefore this can be written as, this can be written as minus 1 minus I and whole to the power 3. Okay, because I square is equal to minus 1, so minus 1 divided by I plus I, so it becomes minus I. So I am taking minus common, So here minus 1 I am taking common, so its power is 3 and 1 plus I to the power 3. So now as you know that the power is odd in the negative 1, minus 1, so it is minus 1, and this is 1 plus I cube, 1 cube plus I cube, and then 3 into A into B, 1 plus I. So now this is equal to minus 1, and I square can be, I cube can be written as minus I because of I square into I, so I square is equal to minus 1, so I cube is equal to minus I. You will just learn minus I in place of this, and 3I, this is 3I multiplied with 1, and then 3I square. This, so here a little bit space is, I am writing over here. So see, minus 1, so 1 minus I plus 2I, this is minus I plus 3I, so it is plus 2I, and this is minus 3, and then minus 1, after that I am doing this, so minus 1 and then minus 2, this is minus 2 plus 2I multiply by minus 1, you will get 2 minus 2I. So answer is 2 minus 2I. So this is the answer of the first question. So answer I am just writing here over this. The answer will be 2 minus 2I. This will be the answer. Now we are coming to the next question. See the next question which I have to do here for any two complex numbers Z1 and Z2. Prove that the real part Z1 into Z2 is equal to real part Z1 into real part Z2 minus imaginary part Z1 minus imaginary part Z2. So now let us suppose solution Z1 is equal to x1 plus iy1 and Z2 is equal to x2 plus iy2. As you know that the real part of Z1 is equal to x1 over here, and imaginary part of Z1 is equal to y1 or iy1, we can write also iy1, and or simply I am writing. And now real part of Z2 is equal to x2, and imaginary part of Z2 iy2 I am writing. Here I am also writing iy2. Let us see what will happen, because real part is multiplied by iota, then it becomes imaginary. Now first of all we have to find Z1, Z2. So here see, Z1 into Z2 is given, therefore I am finding out the product of these two complex numbers. So x1 plus iy1 and then x2 plus iy2. We will multiply x1, x2, and then we will multiply in this way, and here I will multiply first this, then I square y1, y2. This will give you the real part, and then if we will multiply these two first, so I will be common x1, y2, and this we have multiplied, so I take in common y1, x2, and here in place of I square minus 1. So here just you have to do the multiplication. First you will multiply x1, x2, and then you will multiply this into this, iy1 into iy2, and after that you have multiplied x2 by x1, then you will have to multiply x1 to I by 2, and then after that you will have to you have multiplied already this and this, so you have to multiply this and this first, next. So next this you will multiply. So first of all I have multiplied with this, and secondly I have multiplied with this and this, and the third I have multiplied with this and then this. So anyway, if you will multiply, you will get the same one. So I square is equal to -1. So it is x1 x2 minus y1 y2 plus I x1 y2 plus y1 x2. So now see what is the real part of z1 z2. The real part of z1 z2 is this x1 x2 minus y1 y2. Okay, so see here the imaginary part I have to write only y1, because when it is multiplied by iota it becomes the imaginary number. So here in this and this, in place of x1 I can write real part of z1, and in place of x2 we can write real part of z2, and in place of y1 we can write imaginary part of z1, and y2 is we can write imaginary part of z2. So here in place of this I am writing real part of z1 and then real part of z2 minus imaginary part of z1 y1, and this is all about, and then imaginary part of z2. So hope you will understand. So real part of z1 z2 is equal to this. It is to be proved. So for the proof you will not get the answer. This is the proof part, so hence proved. So this you will understand, I think, easily. There will be no problem at all. So see the proof of this one. So I think it is understandable to you. So now we are coming to the next question. Now here reduce the question number 3 of miscellaneous. Reduce this whole thing, whole complex number in standard form, means in the form of a plus ib or x plus iy. So let z is equal to, I'm taking the LCM over here, 1 minus 4i into 1 plus I, then it is 1 plus I minus 2, 1 minus 4i, keep it inside the bracket, 3 minus 4i, 5 plus I, this. So now 1 plus I minus 2 plus 8i, and this is divided by 1 into all these things, 1 plus I minus 4i, then minus 4i square we can write, and now 3 minus 4i by 5 plus I. So only we have to simplify here, 1 minus 2, so it is equal to minus 1, and this is plus 9i, this one imaginary part. So here here I square is equal to minus 1, so 1, and this is minus 3i, and this is plus 4, and then 3 minus 4i divided by 5 plus I, this. So now minus 1 plus 9i divided by 5 minus 3i. This is 3 minus 4i. Just simplification is this. So now here in the first numerator we have to multiply minus 3 plus 4i minus 1. It is multiplied by minus 1, and then 27i, then minus 36 iota square or I square. I am generally telling I. It is the habit to work that. So 5 into 5, 25. 5 into iota 5i, then minus 15i, then minus 3i square. Hope it is clear. So minus 3 and this it is equal to plus 31i. Then it is I square is this. So in place of I square minus 1, so then it is plus 36. So here is minus, and here is 25, and this is minus 10i, and this is plus 3. So minus 3 plus 36, so it is 33. 33 minus 31i divided by, here is 25 plus 3, so it is 28 minus 10i, 10 iota. After this equation 1 I am written. After this I will do is here, no need, this place I have left. So now we will multiply by its conjugate, by the conjugate of the denominator. So multiply the numerator and denominator by 28 plus 10i, which is the conjugate of this. Only you will have to change the sign between the real and imaginary part. Here is negative, so here you have to take positive. So 33 minus 31i by 28 minus 10i into 28 plus 10i divided by 28 plus 10i. Now we will multiply over here 33 into 28. So 28 and 33 we will multiply 924 is coming, and this is 330i, and this into this 28 into 31 is 28, and then it is 84, so 868, then it is minus 868i and 31i and 10i, so it will minus 310 iota square divided by 28 into 28 we have to do 28 into 28, it is 64, 6, 16, 22, then it is 56, 4, 7, 8, 4, here it is 7, 8, 4, 28 into 10i, 280i, and this is minus 280i. So this, or we can just a square minus b square, we can do it just minus 10i square, so this will cancel out. So it is 924, and here we have to subtract over here 868 minus 330, so we are getting 538, so minus 538i, and this is the iota square, so it is minus 1, so plus 310, and here is 784, and then minus minus plus 10. So this and this, the real part, you will have to add. So 4 and 3 and then 12 minus 538i divided by 794. So 794, we will just cancel out whatever is going to be cancelled. Here is the just a rough work I have done. This is the rough work. So we will take 2 common from the numerator. 6 times it is 1, and then 7, 2 is 4, 2 6 is 2 9, and then this divided by 794. So it is just a minute, it is see here I had done a little bit calculation mistake is done. So here 33 into 28, it is 924, and 33 into 10i, so it is 330i, and here is plus. It is this is I have written minus, so this is plus, here is plus, so plus 31i into this, so it is 868i, 31i into 10i, so plus, it is plus 310i square, iota square, and this is a minus b and a plus b, so it is a square minus b square. So no need to multiply. I have just multiplied it with the distributive law, so this is cancelled out, and here is 28 square minus 10i whole square. Okay, so 28 square and 10i whole square, it is minus 100i square. Okay, so it is this is the mistake I have done, sorry for that. So I square is equal to minus 1, so it becomes 100. So 784 is as it is, I am writing over here, and then it is 100. Okay, so I am just cancelling this thing, and now I am doing it here. Here I am doing, this is the next over 1234, and then just a minute, not 1200 something, 1200, sorry, so it is 924 plus 330i plus 868i, so it is equal to 1198i, and then it is minus 310 because of plus 310i iota square divided by, it is coming 784 plus 100, so it is equal to, here this will cancel, subtracted. Okay, 924 minus 310, so 4 and then 1 and then 6, so 614 this and this will subtracted, plus 1198i, and this is 884. So now from the numerator we can take 2 common, so 307 plus, it is 5 and 9 and 9 18i divided by 884, so we can cancel out 442 is coming. So now this can be written as 307 by 442 plus 599 by 442i. So therefore z is equal to therefore z is equal to 307 by 442 plus 599 divided by 442 iota. So this is in standard form. Standard form means in the form of x plus iy we have done. So this is the question number 3. Continuation of question number 3. It is continuation of question number 3 of miscellaneous exercise. So now I am coming to the next question. The next question I have already written over here. The question says that if x minus iy is equal to root under a minus ib divided by c minus id means iota d, prove that x square plus y square is equal to a square plus b square divided by c square plus d square. This type of question I have done. One question I have done, but still you will have to do it. It is a simple question. So now here we will do. See solution. Given x minus iy is equal to root under a minus ib by c minus id. So now taking equation number 1, squaring 1 both sides, we get, if we will square x minus I whole square is equal to a minus ib by c minus iota d. This is taken as 2. Taking conjugate of equation to both sides. If you have to on both sides of equation 2, so its conjugate you will have to take x plus iy whole square, and its conjugate will be a plus ib, and its conjugate will be c plus id. This is taken as equation number 3. Now multiply in 2 and 3 means equation 2 and 3. So see what happens. So you will see that x minus I whole square and x plus I whole square, it is equal to a minus b by c minus id, a minus iota b into a plus iota b here and c plus iota d. So here the power is same, so I am just writing the square bracket and power is 2. So x minus iy and x plus iota y, and here is what, a square minus I square b square, a plus b a minus b a square minus b square, here c square I square d square. So it is also a plus b a minus b, so iota square is equal to minus 1 you have to put, and here what will happen, here is same thing will happen, x square iota square y square whole to the power 2. So it is equal to a square, and here if you will put minus 1, so it becomes plus b square divided by c square plus d square. Iota square is equal to minus 1, and here if you will put minus y square, I square is equal to minus 1, then it will come to x square plus y square whole square is equal to say is equal to a square plus b square by c square plus d square. So this is to be proved. Now here we have to convert the following in polar form. So here we have to convert the following in polar form. So first of all I am doing this. First question, let it is z is equal to 1 plus 7i, that is 2 minus I whole square iota whole square. So this is 1 plus 7i divided by